F 802.1p specifies a mechanism to express a cause identifier on each frame. The 802.1p header includes a 3-byte wide priority field indicating a cost level. This standard is an extension of the 802.1q VLAN standard. So this priority or 802.1p is follows the VLAN. So the VLAN ID starts as the first configuration allowed in the envelope frame. The two standard works together that forms P/Q and share bits in the same header. They share bits in that same header or on that same part of envelope frame. With the 3 available bits, 8 classes of service are defined. Class 0, the lowest priority, is for conventional, best effort traffic. Class 7 is the highest priority and might be used for critical routing or network management functions. There is a 7 class. By default, it is class 0. If you want to make it priority, you can use a network, you can manage that to be a class 7. And it is actually used in network management functions. The standards specify how priorities are encoded in packets, but leave the policy that governs which packets should receive which class and the underlying mechanisms implementing prioritized services to be defined by the implementer. So it's up to the implementer to decide which packets or which part of that envelope frame will receive that priority. But the only thing that the policy requires is the position or the part in the envelope frame that requires that to have that priority part to be able to use it in that or to be able to configure it. Thus, the way traffic of one priority class is handled relative to another is implementation or vendor defined. So it depends on your Ethernet or Wi-Fi, whatever link layer 2 you're using. Note that 802.1p can be used independently of VLANs. If the VLAN ID field in the 802.1p/q header is set to 0, we can also use this priority even if there's no VLAN. Let's say you only have that native VLAN in your switches like we discussed in the previous video. The Linux command for manipulating 802.1p/q information is called vconfig. It can be used to add and remove virtual interfaces associating VLAN IDs to physical interfaces. So for you to be able to configure this in Ethernet frame or on your Wi-Fi signal, you need an OS command such as this vconfig for Linux. It can be used to add and remove virtual interfaces associating VLAN IDs to physical interfaces. So it can be used to describe or remove a VLAN ID to a physical interface. It can also be used to set 802.1p priorities, change the way virtual interfaces are identified, and influence the mapping between packets tagged with certain VLAN IDs and how they are prioritized during protocol processing in the operating system. So it can do a lot of configuration, not just priorities, but also the virtual interfaces that are identified, etc. The following commands adds a virtual interface to interface ETH1 with VLAN ID 2. Remove it, change the way such virtual interfaces are named, and add a new interface. Here, Linux vconfig add ETH1 then 2, added VLAN with VID equals to 2 to IF ETH1 Linux. So this add the ETH1 to VLAN ID 2, and then IF config ETH1.2, and here's the result. And then we could remove it using vconfig rem ETH1.2, remove VLAN ETH1.2. So you can see, we can see the broadcast, multicast MTU size here, the metric, the errors of the frame, the bytes, the X bytes, and then vconfig set name type VLAN plus VID. We have set name type for VLAN subsystem should be visible in /proc/net/VLAN/config. Linux hashtag vconfig add ETH1 space 2, added VLAN with VID equals to 2 to IF ETH1. Linux IF config VLAN 002 VLAN 002 link NCAP Ethernet H, etc. So here we can see the default method of naming virtual interfaces in Linux is based on concatenating the associated physical interface with VLAN ID. For example, VLAN ID 2 associated with the interface ETH1 is called ETH1.2. So that's what we meant by ETH1.2, a VLAN ID 2 associated with the ETH1. This example also shows how an alternative naming method can be used, whereby the VLANs are enumerated by the names VLAN. Where is the identifier of the VLAN? So again, this example also shows how an alternative naming method can be used, whereby the VLANs are enumerated by the names VLAN. Where is the identifier of the VLAN? So there's an alternative naming method which we used here, which is vconfig set name _name _type VLAN _plus_vid. Instead of that, vconfig add ETH1, if you don't like this ETH1.2. Once this is set up, frames sent on the VLAN's device are tagged with VLAN ID as expected. So any frame sent to that will be tagged the VLAN ID to identify it in the network. So we can see this using Wireshark as shown in figure 3.5. So here, frame tags with VLAN ID as shown in Wireshark. The default columns and settings have been changed to display the VLAN ID and row Ethernet address. So as you can see, VLAN 2 and we have the raw Ethernet address, the destination, protocol, WHO, the bytes, etc. Right? So this figure shows an ARP packet, the protocol. See chapter 4 carried on VLAN 2. We can see that the frame size is 60 bytes, not including CRC. So not including the CRC or the FCS used to check the error. Here 60 bytes on wire. The frame is encapsulated using Ethernet 2 encapsulation. Here Ethernet 2 with type 0x8100 indicating a VLAN. Here virtual LAN 0x8100. So this Ethernet 2, the source is 0x8100 and this is the destination. So it means that it's a VLAN if it's a 0x8100. Other than VLAN header, which indicate this frame belongs to VLAN 2 and has priority 0. So here best effort default 0. This frame is remarkable. All the other fields as we would expect with the regular ARP packet. 802.1ax link aggregation, formerly 802.3 AD. So we discussed some of this in the previous videos already, but we're still gonna discuss this in more details. Some systems equipped with multiple network interfaces are capable of banding or link aggregation. With link aggregation, two or more interfaces are treated as one in order to achieve greater reliability through redundancy or greater performance by stripping data across multiple interfaces. So this is what we used to band multiple ports to be able to serve faster the frame request. Using the IEEE amendment 802.1ax 2008 defines the most common method for performing link aggregation and the link aggregation control protocol to manage such links. So IEEE provided the standard of method to be able to control this, and actually Linux again implement these types of methods and automatic protocol, which is the LCAP. So we discussed this in the previous videos as well. LACP uses IEEE 802 frames of a particular format called LACPDUs. So it uses a particular format of frame. So that envelope frame will vary slightly with this type of frame. Using link aggregation on Ethernet switches that support it can be a cost-effective alternative to investing in switches with high-speed network ports. The reason why it is created is because sometimes instead of investing in a high-speed network ports or ETH0 or ETH1, you may just need to aggregate the ports to be able to serve more traffic. If more than one port can be aggregated to provide adequate bandwidth, high-speed ports may not be required. Link aggregation may be supported not only on network switches, but across multiple network interface cards on a host computer. So this link aggregation not only support just on switch, but it could also support a multiple host or multiple ports without switch. Often aggregated ports must be of the same type, operating in the same mode like half or full duplex. So we will discuss this in further details when we encounter the switch on how the frames actually looks like, on what it means by having a half or full duplex. So they must be on the same type to be able to be aggregated. The switch also must support or operating in the same mode or must support that same IEEE standards. Linux has the capability to implement link aggregation or banding across different types of devices using the following commands: modprov banding, ifconfig band 10.0.0.111, netmask 255.255.255.128, Linux if enslave band 0, eth 0, wlan 0. This set of commands first loads the banding driver, which is a special type of device driver supporting link aggregation. So there is a special type of driver that support link aggregation. We discussed this. It's part of a Linux importation of one of its key drivers. So the second command creates the band 0 interface with IPv4 address information provided. So it provides band 0 kind of like the master. Although providing the IP related information is not critical for creating an aggregated interface, it is typical. So though we don't need the IP address in compiling or aggregating network ports, it is typical to add that, because remember the IP is in layer 3. So once the if enslave command executes, which is this if enslave band 0 eh1 wlan 0, the banding device band 0 is labeled with the master flag, and the ETH0 and WLAN 0 devices are labeled with slave flag. So here, band 0 link NCAP Ethernet hardware 0011A3002C2A. So in this example, we have banded together a wired internet interface with a Wi-Fi interface. So these are the Ethernet, so band 0, we have a wired Ethernet interface with a Wi-Fi interface. The master device, band 0, is assigned the IPv4 address information. We would typically assign to either of the individual interfaces, and it receives the first slave's MAC address by default. So here, this band 0 received the first MAC address by default. So we have here broadcast mask, broadcast packets, errors, collisions, bytes, etc. The individual interfaces and it receives the first slave's MAC address by default. When IPv4 traffic is sent out of the band 0 virtual interface, there are a number of possibilities as to which of the slave interfaces will carry it. So the slave, there's a lot of, there's 4 possibilities to be exact, like we discussed in the previous videos on how the slave will carry it. In Linux, the options are selected using arguments provided when the banding driver is loaded. So there's an argument, you're gonna select it via mode or configure it via the name of the mode. For example, a mode option determines whether round-robin delivery is used between the interfaces. One interface acts as a backup to the other. The interface is selected based on performing a XOR of the MAC source of the destination addresses. So they perform a round robin by performing a XOR of the MAC source and the destination addresses. Frames are copied to all interfaces. 802.3 AD standard link aggregation is performed, or more advanced load balancing options are used. The second mode is used for high availability systems that can fall over to a redundant network infrastructure if one link has keys functioning. Detectable by MII monitoring. See band for more details. The third mode is intended to choose the slave interface based on the traffic flow. So this third mode is intended to choose the slave interface based on the traffic flow. With enough different destinations, traffic between the stations is pinned to one interface. This can be useful when trying to minimize reordering while also trying to load balance traffic across multiple slave interfaces. The fourth mode is for fault tolerance. The fifth mode is for use with 802.3 AD capable switches to enable dynamic aggregation over homogeneous links. The LACP protocol is designed to make the job of setting up link aggregation simpler by avoiding manual configuration. So instead of setting it up via mode, these are automatic, but it requires again unique Ethernet frame and protocol. So typically the LACP actor, client, and partner server send LACP-DUs or its unique frame every second once enabled. LACP automatically determines which member links can be aggregated into a link aggregation group and aggregates them. This is accomplished by sending a collection of information, MAC address, priority, port priority, port number, and key across the link. So it automatically finds which slave interface could be aggregated by sending a collection of information like MAC address, port priority, port number, and key across the link. A receiving station can compare the values it sees from other ports and perform the aggregation if they match. Details of LACP are covered in 802.1AX 2008. So the receiving station, after that LACP aggregate, it can compare the values it sees from other ports and will perform the aggregation if they match. So the details of DACP are covered in that IEEE standard. So recall what banding means. In Linux, banding or link lets you combine multiple network interfaces into one logical interface called a band. This band can operate in different modes, each changing how traffic is split, balanced, or made redundant between the slave interfaces, the physical NICs. The Linux banding command structure. There are two main ways to specify the banding mode. Option A with modprobe. When loading the banding driver, sudo modprobe banding mode equal the number, and then MII equals to 100. Option B with IP commands, which is the modern application of this, the modern syntax. Sudo IP link add band 0 type band mode and the mode name. So this is where you will put the 4 types of mode that can be configured. Remember, it's not using LACP. If you're gonna configure it like this, then you enslave physical interfaces. Sudo IP link set ETH0 master band 0. Then sudo IP link set ETH1 master band 0 and bring it up. Sudo IP link set band 0 up. So that's how you activate it. So the banding modes and their meaning. So the 0 balance, the keyword there is balance. This is the name that you would put, balance dash RR. So the function is this is round robin. Packets are sent in sequence through each slave NIC. Example use simple load balancing but me reorder packets. And then for mode 1, active dash backup function, high availability, one NIC active, others standby. Example use redundant networks or failover setups. Mode 2, balance dash ZOR. ZOR based on max/IP, same source/dest pair uses same NIC. Example use balances multiple sessions with predictable routing. So if you want to balance multiple sessions with predictable routing, you use this mode. Mode 3, broadcast. It sent all frames to all interfaces. Very fault tolerant, like critical SCADA systems. Mode 4, keyword for mode, 802.3 AD. Function LACP, IEEE 802.3 AD, dynamic aggregation. Example use, switch supports LACP, load balancing plus redundancy. So actually, we have a keyword for LACP in Linux, which is make it advanced. That allows it for automatic configuration like that. Mode 5, balance dash TLB, adaptive transmit load balancing, switch independent load balancing. Balance dash ALB, adaptive load balancing, EX plus RX. Example use switch independent two-way load balancing. Example of real Linux command for each mode. So mode 0, run robin, sudo mod prod banding mode equals 0, MIIMON equals 100, sudo IP link add band 0, type band mode balance dash RR, sudo IP link set ETH0 master band 0, sudo IP link set ETH1 master band 0, sudo IP link set bands 0 up. Mode 1, active backup. Sudo mod probe banding mode equals to 1, MIIMON equals 100, sudo IP link add band 0 type band mode active backup, sudo IP link set ETH0 master band 0, sudo IP link set ETH1 master band 0. Use case high availability. If ETH0 fails, ETH1 takes over. Mode 2, ZOR load balancing by flow. Sudo IP link add bands 0 type band mode balance dash ZOR. Sudo IP link set ETH0 master band 0. Sudo IP link set ETH1 master band 0. Uses source MAC to destination MAC %slave underscore count to pick the interface. Mode 3, broadcast. Sudo IP link add band 0 type band mode broadcast. It sends every packet out of both NICs. It's rare, used for industrial redundancies. Mode 4, 802.3 AD dynamic LACP. Sudo IP link add band 0 type band mode 802.3 AD. Sudo IP link set ETH0 master band 0. Sudo IP link set ETH1 master band 0. It works with LACP capable switches. Must also configure the switch. So this is how we configure the switch. When we does this LACP switch config, then switch config dash if dash range. So for switch config, that's an interface range. It could GI 1/0/1 to 2. Switch config dash if dash range is channel dash group 1 mode active. Switch config dash if dash range switch port mode trunk. This is the standard IEEE 802.3 AD link aggregation mode. Mode 5, adaptive transmit load balancing. Sudo IP link add band 0 type band mode balance TLB. Load balances outgoing traffic without requiring switch configuration. Mode 6 adaptive load balancing. Sudo IP link add band 0 type band mode balance ALB. Load balances both TX and RX direction. Thus ARP negotiation tricks. How this ties to your coded exploitation? In Linux, the options are selected using arguments provided when the banding driver is loaded. That argument is the mode number or keyword like mode equal 1, active, it means active dash backup, or mode equals to 4 is equals to 802.3 AD. That's what determines how the WAN behaves. So relation to Ethernet frame and TCP IP stack. So layer L1 physical function the cables ETH0 ETH1 bandings role multiple physical links exist. L2 data link Ethernet frames MAC addresses bandings roles banding decides which NIC send each frame depending on mode. L3 network function IP packets right on top of the banded interface like band 0. L4 to L7 function TCP or applications bandings role unaffected by which NIC sends the packet. So banding only changes what happens below IP at layer 2, but the TCP or IP stack above just sees band 0 as one logical Ethernet interface. So these are the quick summary of how to visualize this. So you can see these are the TCP or IP stack at the top. L3 plus only one interface. For L2 we have band 0 logical phase. Banding driver decides how to send frames. And the physical NICs we have ETH0 and ETH1.